Sketch each of the following, stating their domain and range. So we've got y is equal to mod x squared plus 3. So the modulus is actually redundant for this question because x squared plus 3 is never negative. So when we draw y equals x squared plus 3, we don't need to change anything about it. The modulus function is exactly the same. The domain would be all real values. The range would be y is real, but it's greater than or equal to 3. Here we have y equals mod x plus 1 x minus 2. So if we think about that without the modulus, that is going to have x-intercepts at -1 and at 2. And it's going to be, because when you expand that out, x squared will be positive, it's going to be a happy parabola like this. So the modulus of that is going to be the same where we're above the axis, and then this part is going to reflect up. So you might want to put the y-intercepts on here, so that would actually be 2, because this one is -2 down here. Just substitute x equals 0 in here. So the domain would be x is a real, and the range would be y is a real greater than or equal to 0. Then we've got y equals tan x. This one's mod tan x. Well, let's think about tan x. Well, we know that there's a vertical asymptote here, x equals pi by 2, and there's one over here at x equals -pi by 2, and there would be one here where x is 3 pi by 2, and one over here where x is -3 pi by 2. And then the tangent graph goes like this, and in here go through there at pi, and it goes like that, and same thing here, that will be at -pi, and it would do that. And so when we do the modulus, that bit under there is going to reflect up. The same thing here, like so, and over here that will be the same, that will reflect up. And so we have the domain is x is a real, but it doesn't take values that are odd multiples of pi by 2. So we can say x is not equal to 2n minus 1, that makes sure it's odd, pi by 2, where n is an integer. Y belongs to real, y is greater than or equal to 0.